Lately, my screen has been flooded with all sorts of AI terms. Agent, MCP, function calling. But what do they even mean? Some people say an agent is an intelligent entity. But what exactly is an intelligent entity? Others claim MCP is the USB protocol of the AI era. So does that mean it can connect to a USB drive? What's the real story behind all these terms? In today's video, I'm going to use the simplest language possible to connect these key concepts: agent, MCP, prompt, and function calling. Let's tie them all together. Let's dive right in. Back in 2023, when OpenAI first launched GPT, AI felt like nothing more than a chatbot. We'd send a message to the AI model through a chat box, and the AI model would generate a reply. The message we send is called a user prompt. Typically, it's the question we ask or whatever we want to say. But in real life, when we chat with different people, even if we use the exact same words, they'll give different answers based on their own experiences. For instance, if I say I have cramps, my dad might ask me if I ate too much. My boyfriend might ask if I'm sick. My mom might just say, "Oh, okay." But AI doesn't have this kind of persona, so it can only give a generic, safe, and standard answer, which comes off as pretty boring. So we wanted to give AI a persona as well. The most straightforward way is to combine the persona information with the user's message and send it all as a single user prompt. For example, act as my mom. I'm telling you I have cramps. Then the AI might reply, "Oh, okay." That sounds about right. But the problem is, the phrase act as my mom isn't something we'd actually say. It feels a bit unnatural. So people decided to separate the persona information into a different prompt. This is called the system prompt. The system's prompt mainly defines the AI's role, personality, background, tone, and so on. Basically, anything that isn't directly said by the user can be put into the system prompt. Every time the user sends a user prompt, the system automatically sends the system prompt along with it to the AI model. This makes the whole conversation feel more natural. In web-based chatbots, the system prompt is often preset by the system, and users can't easily change it. But usually, the website will offer some settings. For example, ChatGPT has a feature called Customize ChatGPT. Users can write their preferences in there, and these preferences automatically become part of the system prompt. However, even with the perfect persona, at the end of the day, AI is still just a chatbot. You ask a question, and at most, it gives you an answer or tells you how to do something. But you're still the one doing the actual work. So, can we get the AI to complete tasks on its own? The first attempt at this was an open-source project called AutoGPT. It's a small program that runs on your local machine. If you want AutoGPT to help you manage files on your computer, you first need to write some file management functions, like list files to list directories and read file to read files. Then you register these functions along with their descriptions and usage instructions with AutoGPT. AutoGPT then generates a system prompt based on this information, telling the AI model what tools you've provided, what they do, and if the AI wants to use them, what format it should use for its response. Finally, it sends this system prompt along with your request, like "Help me find the Genshin Impact installation directory," to the AI model. If the AI model is smart enough, it will return a message in the requested format to call a specific function. Once AutoGPT parses this message, it can call the corresponding function. Then it sends the result back to the AI. The AI then decides on the next step based on the function's result. This process repeats until the task is complete. Programs like AutoGPT, which are responsible for relaying messages between the model, tools, and the end user, are called AI agents, and these functions or services that the AI can call are called agent tools. However, this architecture has a slight problem. Even though we clearly stated in the system prompt what format the AI should use for its response, an AI model is ultimately a probabilistic model. It might still return content in the wrong format. To handle these non-compliant responses, many AI agents will automatically retry if they detect that the AI returned the wrong format. If it fails once, they'll try a second time. Many popular agents on the market today, such as Klein, still use this method, but this constant retrying feels a bit unreliable. So, the major model providers stepped in. ChatGPT, Claude, Gemini, and others have all launched a new feature called function calling. The core idea behind this feature is unifying format and standardizing descriptions. Going back to the Genshin Impact example, we used the system prompt to tell the AI what tools were available and the required return format. But these descriptions were written casually in natural language, as long as the AI could understand them. Function calling standardizes these descriptions. For example, each tool is defined using a JSON object with the tool's name in the name field, its description in the description field, required parameters in parameters, and so on. Then, these JSON objects were also separated from the system prompt and placed into a separate field. Finally, function calling also dictates the format the AI should use when returning a tool use request, so the format definition in the system prompt can be removed as well. This way, all tool descriptions are in the same place, they all follow the same format, and the AI's responses for using tools also follow the same format. This allows for more specific training of AI models to understand this calling scenario. Even in this case, if the AI still generates an incorrect response, because the response format is fixed, the AI server itself can detect it and perform a retry. The user wouldn't even notice. This not only reduces development difficulty on the user's end, but also saves token costs from client-side retries. Because of these benefits, more and more AI agents are now shifting from using system prompts to function calling. But function calling has its own problem. There's no unified standard. Each major company's API definition is different, and many open-source models don't yet support function calling. So, writing a truly cross-model compatible AI agent is actually quite a hassle. Therefore, both methods, system prompts and function calling, currently coexist in the market. Everything we've discussed so far has been about the communication between the AI agent and the AI model. Next, let's look at the other side. How does the AI agent communicate with agent tools? The simplest way is to write the AI agent and the agent tool in the same program. A direct function call, and you're done. This is how most agents currently work. But over time, people started to realize that some tool functions are quite common. For example, a web browsing tool might be needed by multiple agents. I can't just copy and paste the same code into every agent, right? It's too cumbersome and inelegant. So people came up with an idea: turn tools into services, host them centrally, and let all agents call them. This is MCP. MCP is a communication protocol specifically designed to standardize how agents and tool services interact. The service running the tool is called an MCP server. The agent calling it is called an MCP client. MCP defines how the MCP server communicates with the MCP client and what interfaces the MCP server must provide. For example, it needs interfaces to query which tools are on the MCP server, the tool's function, description, required parameters, format, and so on. Besides regular tools in the form of function calls, an MCP server can also directly provide data, offering services similar to file read-write, called resources, or provide prompt templates for the agent, called prompts. The MCP server can run on the same machine as the agent, communicating via standard I/O, or it can be deployed on internet communicating via HTTP. It's important to note here that although MCP is a standard customized for AI, MCP itself has no direct relationship with the AI model. It doesn't care which model the agent is using. MCP is only responsible for helping the agent manage tools, resources, and prompts. This is how system prompts, user prompts, AI agents, agent tools, function calling, MCP, and the AI model are all connected and how they differ. They don't replace each other. Instead, like gears in a machine, they work together to form the complete system of AI automated collaboration. This is Ada's Code. See you next time.